In section 4, we're going to take a deep dive into firewall rules and network address translation. In this section, we have 3 lessons, the first of which is firewall concepts and principles, followed by port forwarding and network address translation, and we'll complete the section with a look at demilitarized zones. Before we begin the section, I thought it might be interesting to look at a graph representing the number of data breaches and millions of records exposed over the past 13 years. As you can see, the rise in attacks has been going up exponentially, while the number of records exposed may not be directly correlated to the number of attacks. And you can be sure that both of these numbers are being underreported. So as you can see, in today's internet environment, it is every day more and more important that you protect your network and information resources. It is important to understand the mechanisms which lie beneath address translation and firewall rules. These features are provided by pf, which is short for packet filter, and that is the packet filtering program used by the BSD operating system underlying pfSense. The pf in pfSense stands for packet filter. At its core, pfSense is a packet filtering machine. It inspects packets traversing through the networks attached to it. The firewall and address translation filtering that are performed by pf occur in a sequence, and it's important to understand how that sequence will be processed when you create the rules for various situations on your pfSense network. Looking at these features individually, we can see that the first and most important part is the processor, and that is pf. pf is actually a command line program built into the operating system, and it is used to configure address translation and firewall rules. This can be done from the command line, either at the console via the web configurator executing one command at a time, or from a SSH virtual console session. Address translation is generally processed ahead of other firewall rules and includes both network address translation, otherwise known as NAT, and also port address translation, which is sometimes called PAT, but more generally called port forwarding. Address translation basically takes network traffic from one interface and passes it to another interface under a specific set of circumstances. This is useful, for instance, if you have a web server inside a private network and you only have one public IP address, then you can forward traffic from the web ports of that public IP address into the internal network so that the web server can be reached from outside of the actual network that it is attached to. Firewall rules control whether network traffic is allowed or denied to pass through an interface. These rules can be applied in a variety of ways and are processed in a top-down order. These rules will allow you to selectively allow traffic to cross from one interface through and into another interface's network, or deny that traffic from being allowed to pass. And we will get into looking at those firewall rules in greater depth right now in this video, Firewall Concepts and Principles. So what exactly are firewall rules and how do they work? A rule defines a condition and it performs one of 3 actions dependent upon the valuation of that condition. A condition is comprised of a source and destination network or address, either of which may be wildcards, and the interface to which the rule applies, and other options such as logging. When a packet matches a rule condition, pf will either let the traffic pass or deny the traffic with an optional rejection message. The rejection mechanism is rarely used because it is generally wiser to pose as if there is no service or computer at the endpoint in question, rather than tell a potential attacker that there is a computer there. It is just denying their requests. Note that denying the traffic is not 100% foolproof. There are ways to detect that traffic is being denied even if you are not sending the optional rejection message. In this video, we will review the previous firewall rules that we have created and discuss rules required for the next section. We will also look at how to schedule rules to occur only during certain times of the day. It is important to take a moment and note that improper configuration of firewall rules will lead almost surely to network compromise. Therefore, when you are creating or modifying existing firewall rules, it is extremely important to double and triple check that you have everything set properly, and then validate that configuration with proper testing so that you do not inadvertently expose your resources to potential attackers. We'll begin where we left off in section 3.3, looking at our firewall rules as they stand with the wide area network, LAN, opt1, and opt2 interfaces all active, and with DHCP servers active and no network bridge. We currently have the single firewall rule on the wide area network, which blocks the bogon networks. You'll recall that we removed the rule that blocked the RFC 1918 networks from reserved local network subnets. And then we'll look at the local area network, and you can see that we have our anti-lockout rule running on ports 80 and 443, allowing traffic from the LAN to the LAN address, which is 10.0.0.1. We are allowing traffic from the opt1 net, denying traffic from the opt2 net, which will be our public services, and the opt1 net is essentially going to be our segregated internal network, and the LAN is allowed to send traffic everywhere else. The opt1 network is in pretty much the same state, except we do not have the anti-lockout rule. We are allowed to reach the LAN, we are not allowed to reach opt2, and opt1 traffic is allowed out. In the opt2 interface, we are denying traffic to the LAN, to opt1, and allowing traffic to everywhere else. One type of rule that we have not talked about that is worth mentioning is the floating rules. And in the floating rules, you can do a lot of very interesting tricks. For instance, you can create rules that apply to multiple interfaces. You can create rules for outgoing traffic from the wide area network interface, which you cannot do in any of these other rules. And you can use them in traffic shaping, as well as many other uses. We're going to spend our time setting up our network, at least a little bit, for the last video in this section, the secure complex network. So to begin, we're going to want to allow some traffic from the wide area network into pfSense. Since the opt2 network is our public subnet, we will add a firewall rule to the top of the list, allowing traffic to pass. We'll leave it enabled on the wide area network interface, IP4 traffic, and we will allow any protocol to reach the opt2 address. And save. On the LAN interface, we're going to swap the rules for opt1 and opt2 around a little bit and pretend that the opt1 network, which we're block traffic to, is going to be a secured part of our imitation corporate network. So we could say that maybe it's the high security robotics laboratory, And so we will block all traffic to that and save. And since it's high security, let's go ahead and log packets that are handled by the rule. And now we will allow traffic to the opt2 net and save, since that is the public network and we can do further firewalling on that interface itself. So for now, from the LAN interface, all ports and all traffic on the IP4 protocol are allowed through to opt2, while none are allowed through to opt1. In the opt1 network, which is our secure robotics laboratory, we are allowing traffic to the LAN net, and we will go ahead and allow traffic to the opt2 network as well. However, we will, at the top of the rule set, add a rule to block traffic on this interface and any protocol from reaching the WAN at all. And go ahead and log these packets and save. So now we have our secured robotics laboratory unable to reach the internet, but able to reach printers in the normal part of the office, the LAN net, and also able to reach and manage services in the public opt2 net. We will also go ahead and add a couple explicit rules to make sure that on this interface we are blocking traffic from the LAN itself and also blocking traffic from opt2, so that if our public network is exploited, they cannot reach this interface or anything behind it. Go ahead and check the rule order. We'll make sure to put the WAN blocker up at the top. And now you can see that we have a secure network that can send traffic to the LAN and to the public services network. However, it is blocking traffic from all of those. You can see that we need to update this rule. We'll stay on the page, save this, edit this rule, and make the correction here. And save. It's always good to double and triple check your rules before you apply. And now you can see that if it's from opt2 or the LAN, it will be blocked. And moving to the opt2 network, which will be our public services interface, to allow traffic on the opt2 interface with the TCP protocol with a destination of the opt2 net on the HTTP port, and click save. We'll go ahead and copy this rule and allow traffic on the SSH port as well, and save. Now we'll check out our rules for the public network and their locations in the chain. We want to make sure we're always denying those. These are allowed to go out, and if the destination is the opt2 net, it will be allowed to pass if it's on one of these two ports. Now the important thing about firewalls and their ports is that you must know your applications and services that you are offering and what ports they are running on. Many programs have a standard port set, and almost all programs can have their ports changed to something custom. So that is part of the research and knowledge that you must attain in order to effectively manage your firewall rules. Now that we have a fairly complex set of firewall rules, we'll go ahead and check all those, and we will apply the changes and check the monitor to ensure that it has reloaded. As you can see, our rule set page is growing. Now we will take a quick look at the Firewall Rule Scheduling feature, which is under Firewall Schedules. We'll add one. We'll call this pfSchedule and enter a description. And now we'll go ahead and pick a month of February, and then we'll pick a few dates, and we'll leave the time set from 0 to midnight and call this 3-day blocker. We'll add that time. As you can see, you can add more times, and we can call this 1 day blocker. We'll add that time, and now we can save this schedule, and we have a schedule that is available to be applied to a firewall rule. We'll go ahead to the firewall rules. We'll add a rule that is block on the interface WAN, any protocol, any source, and any destination. So we will block all traffic, and we'll log all of that traffic. And since we want to apply that to our schedule, we'll display the advanced and move down towards the bottom to the schedule tab, and we'll click the pf schedule and save. Now we have a scheduled rule for the wide area network to block all traffic on the 4 days that we chose in the calendar. We can apply those changes. However, since we don't actually need to do that, we'll just go ahead and delete that rule and go back to the schedule and delete the schedule, which we would not be able to do if there was still a rule using it. So that is a more detailed look at the firewall rules as they apply in the context of our course.